right, students, I'm sorry I couldn't be there today. Yesterday we started talking, I asked this one question of how can you tell if something is moving? And it's kind of a hard question to answer without actually using the word moving or motion. But what motion is when something changes position relative to what we call a reference point or other objects that we know for a fact don't move. Then that's how we can really tell if something is moving. It can kind of trick our brain if we don't use a correct reference point. So normal reference points are things that we know for a fact do not move. They stay in its place, like trees or buildings. We know those things don't move. So when an object is changing position relative to that reference point, then we can tell if that object is in motion. So we're actually not really watching the object itself moving. We're watching the object in relation to all the other objects around it that appear to stay in place. Which is why our brain can play tricks on us a little bit. Like when you're in a car and you look out the window and you see a car and it looks like it's going the same speed as you, or it's not moving at all. It's because it's actually going the same speed as you and your brain is using it as a reference point. So reference points in motion can get a little tricky, and that's where you get all the brain twisters that you guys can look at. But motion is changing position over time relative to those reference points. That's when something is in motion. Now with motion, we have several ways we can measure it. Most of these words you've probably heard before. We're going to be talking about speed, velocity, and acceleration. All three ways to measure motion. The first way we're going to talk about measuring motion is this thing called speed. Now you guys probably know the speed limit signs. You get usually 25 miles per hour or 30 miles per hour. You could do kilometers per hour. We like to do meters per second in science, mainly because we're not going to be going a long distance. But all of those meters per second, miles per hour, kilometers per hour, those are all indicators of speed. We know that speed is how fast you're going. Technically speaking, it's the distance traveled by an object for a unit of time. But we like to call it how fast you're going. We know this. The one thing about speed is speed has to have units. If you don't have units, it is wrong. The one we like to use is meters per second. It's the one we're going to be using in class unless I give you another variable. Kilometers per hour is used in Europe. Miles per hour is used for cars. So just make sure you have your units. Okay? The main thing we're going to be doing with measuring motion is calculations. This is physics after all. So I want you to write down this formula here. Speed, abbreviated as a lowercase v, don't ask me why yet, but just write it down, equals distance divided by time. Distance is represented by a d and time is represented by a t. So shorthand, you could say v equals d divided by t. So speed equals distance divided by time. Now I love the triangle trick. With the triangle trick, you can solve anything. So let's take a look. We already have the formula for speed. So we can cover up speed here. And you can see that by covering up speed, you have distance divided by time. We already have that equation. But let's say we wanted to find for distance. So if we want distance, we're going to cover up distance, who's in the top point, and we get speed next to time. When things are next to each other, we know that we multiply. So our equation to find distance is speed times time. Well, let's say now we wanted to find time. Just cover up your unit for time, then you are left with distance over speed. When something is on top of the other, we divide and you get the equation time equals distance divided by speed. So with that triangle, you can solve for any variable that I give you. Most likely, we're going to be just solving for speed, but you might see some problems that are solving for distance and time as well, and the triangle trick helps if you don't like manipulating the variables. Alright, let's practice one. So this problem says, what is the average speed of a car that travels 80 kilometers in 1.5 hours? Now, I know a lot of you like to do this in your head, and that's fine. Humor me for a minute. Let's write it out and let's break it into what we need to solve for. So what we're looking for is we're looking for the average speed of this car. What are we given? We're given these two numbers, 80 kilometers and 1.5 hours. So we know that 80 represents our distance and 1.5 hours represents our time. So then we want to know our relationship. That's your equation. So your equation to find speed is speed equals distance divided by time. Now that we have everything that we need, we can solve this problem. Anytime you do a problem, homework, test, anything, you need to show how you got it. If you just give me the answer, I have no idea how you got it. And if you got it wrong, then I can't give you partial credit if you don't show me how you got it. Okay? So let's set this up. Speed equals distance, which is 80 kilometers, divided by time, which is 1.5 hours. If we take that and plug it into your calculator, 80 divided by 1.5, you get 53.3 kilometers per hour. The unit is important here. Whatever unit I give you in the problem, that's the unit you're going to be using for your answer. So in this case, I gave you kilometers and hours, so your answer should have kilometers and hours. So far, that's all we're doing. It's just a simple equation to solve for speed, which you already know is how fast something is going. It's a way to measure this thing called motion. And remember, motion is when something is changing position relative to these reference points that we use, things that stay still. So far, so good? Sometimes I'm going to get a little tricky. Sometimes problems might ask you for the average speed. Average speed is really not any different from normal speed. Normal speed is distance divided by time. Average speed does not mean you're going to add everything up and divide by however many you have. Average speed just means that you're taking in consideration the total distance traveled by the total time passed. Think about this. A lot of the times, you're not walking to class at one speed. Sometimes you're going really slow. Maybe you get stuck behind a bunch of people. Maybe you're in the stairs. Maybe the bell rings and then you start running to class. So we can't actually calculate your speed in any given moment of that and call it average, because average, you're not going one speed. So an average speed is taking into consideration all those things. Maybe you stopped and talked to a friend before running to class. So when I ask for average speed, I just want your total distance divided by your total time passed. Most of the time when you get an average speed problem, it's going to be related to a graph. So let's take a look at this graph down here. Motion of two joggers. The little circle, these are Kathy. So this is Kathy's line up here. And then this is Rachel. So we're going to learn how to really talk and look about graphs tomorrow. But for now, let's see if we can read this one. Let's calculate the average speed of Rachel. So she's this line. The first thing we want to do is we want to take a look at what's going on here. So it looks like the race started here at 0. Well, it looks like Rachel, maybe she was tying her shoe because she didn't start running until 2 minutes have elapsed. So it took her 2 minutes to even start running. Then she started running, but then something happened right here at about the 7-minute mark. She stopped moving again. Her total distance did not go further than 600. She did not finish the race. So when we take a look at this graph, you really only need to focus on this last point here. This line, these lines are telling us a story that she did a lot more than just run a race. Maybe she didn't start, she ran, and then she stopped. But when you're calculating average speed, you should only be concerned with this last point, because this last point tells you the total distance she traveled and the total time that she did it in. So looking at this point, the total distance that Rachel traveled was 600 meters. The total time that it took her to run 600 meters, regardless of whether she stopped or not, was 10 minutes. So now that we have her total distance and her total time, we can do a calculation. So her total distance was 600 meters. Divide that by her total time of 10 minutes, you get 60 meters per minute. So her average speed in this race was 60 meters per minute, even though we know at some point in the race she was going 0 meters per minute. But average speed takes in consideration of the total race, the total distance divided by your total time. The next thing we're going to talk about is this thing called velocity. Now, a little while ago, I gave you the equation for speed. Speed equals distance divided by time. But the abbreviation for speed was not S, it was V. That's because V stands for velocity. So why didn't I just give you velocity equals distance divided by time? Are speed and velocity the same thing? Not exactly. Velocity is just speed and a direction. So it's speed plus a little bit extra. So when I ask you what is the speed of the car, you can just give me a number, 30 miles per hour. However, if I ask you for the velocity of the car, I also need the direction. So is it illegal to drive 30 miles per hour in a 30 mile per hour zone? It can be if you're going the wrong way. So the direction here matters. So speed and direction is velocity. Because it's pretty much the same thing, the equation is the same. The only difference here is you have to have this direction. So velocity is speed and a direction. So if I'm asking you for velocity, you better have a direction with it as well, such as 5 meters per second east, 5 meters per second west, north, south. I just need a direction with your velocity. Now your velocity is represented by arrows. These arrows are called vectors. Vector meaning they have magnitude and direction. Magnitude means strength. You guys ever seen that Despicable Me movie? Vector, committing crime with magnitude and direction? That's vector. Magnitude is how big it is. And then obviously the way it points is your direction. So like I said, if I ask you for velocity, I need a direction. Direction can be right, left, up, down, forward, backward, down, south, north, west, east. Give me a direction with your speed. That's velocity. Don't let that trick you on a test, quiz, anywhere. Needs a direction. And the last way to measure motion is this thing called acceleration. This is where we're going to get a little tricky. Acceleration's definition is a change in velocity over time. Now, we just went over velocity. Velocity is speed and direction. So if acceleration is a change in velocity, that means acceleration can refer to 3 different things. You can change your speed, speed up or slow down, or you can change your direction. Speed and direction are both velocity. A lot of the times when we hear the word acceleration, we think of speeding up, going faster. But that's not exactly true. Acceleration refers to 3 things. You can increase your speed, speed up, decrease your speed, slow down, sometimes called deceleration, but that's technically not a science word, so we use slow down instead. Or change direction. All 3 of these things are technically classified acceleration. So this is where it gets a little tricky. Most people always forget this changing direction thing. So acceleration means change in velocity, speed, or direction over time. Again, because this is physics, we have another equation you'll have to know. To calculate acceleration, it's a little bit on the scary side. So we have acceleration, which is abbreviated by a little a, equals final velocity, abbreviated V sub f, minus initial velocity, abbreviated V sub I, divided by time, which is not an S. Sorry, that's supposed to be a T. This is the equation for acceleration. Final meaning that's the speed that you end at. Initial velocity is the speed that you start with. A lot of times, initial velocity, 0. But make sure you read the problem just in case. It's not always 0, but a lot of times it is. So to set this up, we can also use our triangle again. So this time we're going to have velocity on top, acceleration and time on the bottom. We already know if we cover up acceleration, it's velocity divided by time. Now this gets a little tricky because technically there are two velocities in that category. Final velocity minus initial velocity. But again, a lot of times initial is 0 divided by time. We got that. Well, let's say you're looking for velocity. Maybe it's final velocity or initial velocity, but either way you're looking for velocity. What you're going to do is cover up velocity, and you get acceleration times time. Well, let's say you wanted to find time. You would just take velocity and divide that by acceleration to get your time. So again, the triangle trick does help you figure out other pieces of this equation. The really difficult part here about acceleration are the units. So notice, the top here is our velocity. Velocity is measured in meters per second. It already has a distance over time unit on here. So we have meters per second, but we're dividing it by time. Time is also in seconds. Because we're dividing them and they're both seconds are on the bottom, you can't get rid of them. They don't cancel. Instead, we say acceleration unit is meters per second, or meters per second squared. We have two S's here. They don't cancel. We just add a second one. So meters per second squared, or meters per second. Remember, units matter. All right, let's try one for practice, and then I will let you get started on your practice problems for homework tonight. So this problem says a skateboarder is going downhill at a speed of 4 kilometers per second. The hill gets steeper and his speed increases to 7 kilometers per second in 3 seconds. What is his acceleration? Again, humor me. Let's figure out and break this problem up, because if you do it wrong and put one velocity in front of the other, you could get a different answer. So we are in fact looking for acceleration here. We're given 3 different numbers: 4 kilometers per second, 7 kilometers per second, and 3 seconds. This one, he says he's going downhill at a speed of 4 kilometers. Notice he does not exactly say initial and final. That's where you have to really read the problem and figure it out. Since he's going downhill at a 4 kilometers per second and the hill gets steeper, his speed increases too, which means 7 kilometers is his final velocity. He starts at 4. So we have our initial velocity is 4 kilometers per second. Final velocity is 7 kilometers per second, and that leaves us 3 seconds, which is our time. Remember, our equation is acceleration equals final velocity minus initial velocity divided by time. You're always going to do final minus initial. A lot of the times, it'll be a positive number. However, sometimes you will get a negative number. Positive number means that your speed is increasing. A negative number means that your speed is decreasing. Other than that, the negative and positives don't really do much to it. It just tells you if you're speeding up or slowing down. There is no positive or negative for changing direction. All right, so let's solve this. So we're going to plug in our numbers. 7 kilometers per second minus 4 kilometers per second divided by 3 seconds. The first thing you want to do is 7 minus 4, which happens to be 3 kilometers per second divided by 3 seconds. This is an easy problem. You can do this in your head. You end up getting 1 kilometer per second, or 1 kilometer per second squared. Remember, both seconds count. You cannot cross them out. So it's 1 kilometer per second squared. Try the practice problems that the sub has for you. You have a sheet on speed and a sheet on acceleration. I will check them tomorrow, and then we are going to learn how to read our motion graphs to tell a story with our motion problems. Have a good day.